Hi guys, welcome to Science in 5. In this video, we're going to talk about adding vectors in one dimension using a calculation technique. Vectors have magnitude and direction. To add vectors, we must do it algebraically. Vectors in algebra, is this not complex? Well, not really. If you remember, in algebra, if we had 3a plus negative 5a, this simplified to negative 2a. If I had 3p plus 4p, the answer was 7p. Or if I had negative 4m plus negative 10m, this became negative 4m minus 10m to give me negative 14m. So in algebra, terms can be positive or negative. Vectors can also be positive or negative. What then is a positive vector? What then is a negative vector? If I look at this diagram, I've got a horizontal axis with 0 in the middle. If I move along this axis in the eastern direction, I'm going to the positive direction. If I move to the west on this axis, I'm going in the negative direction. So a positive vector is a vector that is pointing or it's acting in the eastern direction. Similarly, a negative vector has got its action into the negative direction. Notice when we graph vectors like this, we can see that the vector has two parts. A tail, this long straight line, and then a head, the arrowhead. So the arrowhead is what tells me the direction of the vector. And the tail tells me how big the vector is. The bigger the vector, the longer the tail is going to be. The vector is measured from the tail all the way to the end of the head. That's how big the vector is, okay? So the vector is always measured from the tail to its head. That's how big a vector is. So A is 14 units. So if you count these units all the way from the tail to the end, you'll get 14. Same with B. Notice it doesn't matter whether A is placed on the negative values of the axis, it's still a positive vector because its direction is positive. It doesn't matter if vector B is placed in the positive side of this axis, it's still a negative vector because it's going in the negative direction. So to add these two vectors, it's similar to adding a positive 14 and a negative 15. So what's 14 plus negative 15? It's a negative 1. Negative 1 simply means 1 unit in the western direction. So my final answer will not be a negative. Is going to be a positive answer, 1 in the western direction. Similarly, if I had vectors acting vertically, E is 19 units down, negative, D is 10 units up, positive. The sum of these two vectors is going to be 9 units downwards. Because according to this system of axes, upwards is positive on the Cartesian on the y-axis, downwards is negative. So the result is positive 10 plus negative 19 to give me 9 units down. It's practice time. There are a couple of questions. Press pause, and then when you're ready, press play to check the answers. As soon as you're ready, you just press play again, and then the answers will appear on the board. Question 1. We are given vector A is 2 units east and vector B is 7 units east. We want the resultant vector. Well, the resultant vector, in this case I can clearly see that I've got a positive vector and another positive vector. Okay, so in this case I'm going to say east is positive. So if east is positive, VR, or my resultant vector, is going to be 2 plus 7 to give me 9 units. So this is a positive 9, and we know that the positive direction is the eastern direction. So this is 9 units east. Okay. 1.2. We've got P 25 units up, Q 20 units down, and R 11 units up. Well, let's decide which direction is going to be the positive direction, which direction is the negative direction. What if we say up is positive? So which means the vectors going down will be negative. Okay, so which means vector P is a positive vector, vector Q is a negative vector, vector R is a positive vector. So my resultant vector is going to be the sum of all these three. I'm adding them as if I'm adding positive and negative numbers. So it's a positive 25 plus a negative 20 plus 11. This becomes 25 minus 20 plus 11. What's 25 minus 20? 5. 5 plus 11 is 16. So I'm getting 16 units up. Question 2. I'm told that the resultant force that acts in the diagram below is 5 newtons in the eastern direction. So I've got a 19 Newton force going east, a 15 Newton force going west, an 18 Newton force going west, and a force labeled F going east. Again, I need to decide which direction is positive, which direction is the negative direction. So let's say east is positive. So which means the 19 Newton force is a positive force, the 15 Newton force is a negative force, the 18 Newton force is a negative force, and force F must be a positive force. Okay, so when I add all these forces, I'm getting a 5 Newton east, which is also a positive force. So let's add all these forces up and equate it to the resultant, which is 5. So if I add F plus 19 plus negative 15, it's a negative force, it's going in the negative direction, plus negative 18, it's a negative force going in the negative direction, is giving me a positive 5. Okay, we know that when you're adding negative numbers, it's the same as subtracting. So F plus 19 minus 15 minus 18 is equal to 5. What's 19 minus 15? 19 minus 15 is 4, right? What's 4 minus 18? 4 minus 18 is negative 14. So f minus 14 is now equal to 5. What must I do here? I need to get rid of the negative 14. So I must add 14 to both sides of the equation. Okay, I'm going to add 14 to both sides of the equation. So I'm going to add 14 here, add 14 there. I'm going to remain on this side. F equals 14 plus 5 is 19 newtons. My 19 newtons is a positive, so it's 19 newtons east. Thanks for watching, guys. I hope you've developed the skill of adding vectors in one dimension. In the next video of mechanics, we're going to look at how to add vectors in 2 dimensions. That one is quite interesting. So I'll see you guys around next time. Thanks for watching.